Okay, so lesson 27B. How does modifying the linear function in the system affect the number of solutions? So we're going to state the number of solutions for each one of these B values. We got 2, we got -1, and we got -8. We're going to use Desmos to look at the graph and sketch a picture of each. So let's shoot over to Desmos and see what we've got. Okay, so we've got the parabola over there. Let's start with the first one, which is y equals 2x plus 2. Let's see what it looks like. Now, as you can see, it's crossing in two spots. So, I'm not sure they're asking me for, anything but a sketch. So hopefully, oops, that ain't very good. You do something like this, where you can see two different spots, one over here and one over here. Okay, so let's see what happens on the next one. We'll take that one off. We'll turn this one on. Ooh, doesn't it touch in one spot? It does. So got this parabola thing going on here. Whoops, that is a bad looking parabola. Let's try that again. Get this parabola over here and here. Let me just choose a different color. I should probably do it. Sorry, I was going to sneeze. Didn't want to sneeze on camera. All right, so we got this thing going on here, and boom. Once again, that word tangent shows up, where it hits one spot right there. And what happens if, ooh, there's my parabola, and then my line comes through. My dog's sitting next to me. I'm really hoping he doesn't sit there and growl, but he is a golden mini doodle, or actually just, I don't know. But anyway, he's a mini doodle, and they like to bark at all kinds of stuff. Um, so anyway, hopefully he keeps his mouth closed, right, buddy? Anyway, so that's a situation. You got no solution there. Um, One solution and two solutions. So it'd really be nice if we had a way to be able to figure out um, which of the situations we're in, right? Now, so I have shown you, it says problem solving with Desmos. Revenue for the high school band concert is given by this function. All right. So let's try to get this set up. I'll get the graphing set up on Desmos. All right. So as you can see, my picture looks a little wonky. And I've taught you how to do things like, I might have to actually shrink this up. I have taught you how to grab one axis and stretch this out. Now, the reason I need to do that, obviously you're saying to yourself, Mr. Stailey, the picture's not getting a whole lot better. But then if I do the shrinking, it's possible that I'm going to start to get a nice looking picture. Now, where the heck is that line? I thought there was another line. Let me go check and see if I didn't. Oh, yeah, I need to put a line through there. Oh, there we go. If we are using Desmos, which we can for some of these questions, at what ticket price will the band make enough revenue to cover their costs? At what ticket price will the band make enough revenue to cover their costs? Well, I guess the question is going to be revenue for the high school band is given by this function, and the cost of the concert is given by this function. That's weird. So the first time it crosses is at $2.33. And at $2.33, our costs are exactly the same, $420. So this this situation seems a little bit kind of weird. So we want to charge $2.33 a ticket. Now the other one doesn't make sense to me. If I charge $7, the cost is now less. $280. I don't think that part of the graph makes a whole lot of sense. So, because that does, your costs would not be going down. Your revenue would be going up, but your costs would not be going down. That's a strange situation. I don't understand how we have fixed costs, and as the ticket price gets higher, I think, you know what? Yeah, huh. At some point, that function has to fall apart. That situation cannot continue on. So maybe only the first part of the graph, like from here to the vertex, makes sense. Past that, and no, that's really kind of sketchy. I don't think that really makes a whole lot of sense. Okay, so let's switch gears a little bit. Still going to use Desmos, but what if we had y is less than, oops, use the less than symbol. Remember, if you want the equal to, you would have to hit equal after it, but we do not want the equal, so we're going to use the backspace and get rid of it. However, that only gets rid of the equal. It does not get rid of the less than. Negative 2x squared. Notice that it's drawing a parabola, in this case with a dotted boundary line, and it's shading less than that. Now, less than that parabola this time happens to go inside the parabola. If this were a positive, look at how it would shade. The parabola would be going up, but we're still shading down, so it does not go inside. So it's really important to know which way the parabola goes and which way the shading goes, so that you can make a decision on whether it's you've done it correctly. I know some of you just trust what you type instead of actually using your brain, but that's how AI makes mistakes. You guys don't know enough to catch it and say, ooh, that's wrong. So we now have our parabola drawn. It's a dotted line parabola, and it's shaded below. Next, we have a line. 4x plus 1y, is greater than 4. Now, another way to say that would be to get y by itself. In fact, I would probably prefer that. Y is greater than negative 4x plus 4. Now, what section of this graph? Is it this section out here? Is it this section here? Is it this section in here? Is it this section in here? Or is it this little tiny piece right here in between? And yes, folks, that is the answer to my question. The answer to my question. You've got this dashed line thing coming up here. And then you got this ugly looking thing doing like this. And the only part of this that's the answer to this question is the little tiny section where they overlap in the middle. That is the solution to the system. None of the rest of that stuff is a solution to a system. So, I would recommend putting everything solving for y on all of these and graphing them. I know Desmos can handle it without doing that, but I would suggest you graph it just for your own peace of mind, so you can think to yourself, should I be shading up, shading down, to make sure this is right? So, okay, so we got y is greater than, this one's already solved for us, so I'm just going to go ahead and type it in. X squared plus 6x and a minus 12. Okay. I wonder if we should just do this. Yeah, that's not horrible. Yeah, it's not bad. Okay. Now let's come do the other one. And we said that we wanted to get y by itself. So we'll bring that 3x to the other side. Negative y is greater than or equal to negative 3x minus 8. Of course, we'll divide everything by negative 1. And that will flip my sign over and give me 3x plus 8. All right, so now we can come over here and y is less than, put the equal sign on it, which makes it going to make it a solid line, 3x plus 8. So we have, let's try to use the same colors. So we're going to do this. Oops, not the greatest of choices. And then we're going to do, we'll try to use a green. It's not as dark as that green. Let's see. It's crossing here, and it's crossing here, and it bottoms out here. Okay, so something like this. And, oh, poorly done. Dot 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 dot, something like this. So we've got sections, let's see, 1, 2. Now, section 3 would be a big section out here. Section 4 would be all of that stuff in there. And then section 5 is this little tiny section right there. So where do they overlap? As you can see, it is the one that I called section 4 right there in through there. That's where they overlap in there. So you can compare the pictures. All right, on example 3, what if I said y equals x squared plus 9x and y equals 4 minus 3x. Now, I want you to notice what I've done here. Oh, I missed something here. That's a minus 5. I called this one y, and I called this one y. And I put them on the Desmos graph. What am I looking for? Find the x values only where they intersect. No y values. So x values only. That's it. So on my picture, this isn't a great looking picture. Let's see if I can get something that looks kind of nice. So I've got a graph that's doing, oops, let's come back here, scribble. Something that's doing this comes back up like that. Okay. And then on my red one, I've got it crossing something like this. We just want to know the x values only of those 2 points. Now, if you're using Desmos, this is a whole easy thing, right? You're literally just clicking there. Now, be doggone careful with this one right here. Because, some people are looking at the x-intercept, some people are looking at the y-intercept. You got to be looking at the one where they cross. So, yeah, it's easy to see that this x value is negative 12.708. That's one of your answers. But what's the other one? It's 0.708. Now, if you don't know that, then do yourself a favor and just zoom in on it so that you can get a better look. Don't mess that up when you have such an easy tool to use. Now, could I literally, let's see what happens if I type this. X squared plus 9x minus 5 equals 4 minus 3x. Now, as you can see here, it looks weird. It doesn't make sense at all. Right? Two vertical lines? Yeah, see? Just to verify, those are the two answers right there. But I want to see a picture that looks like this, which means don't give me that crap. Graph these two things. Let the calculator show you what the picture looks like. So, when it's setting those, I'm not even sure how it's getting those two vertical lines. It must be solving it for you, which is not what we're going for, because then you don't understand that these are coordinates. These are, you can find the x values, make the solution to the system. Okay, let's go find another one. There's one more here. So we're going to set this one to y and this one to y. Let me get that set up. Well, as you can see, I got my equations, my y set up, right? And let's see, my red one, doing something like this. My black one, let's see, it's crossing here and crossing here. So it's doing something like that. So there's going to be two x values where it's crossing, and probably should zoom in so I don't, make a mistake on that. So we got one x value there and one x value there. So it looks like one of my answers is negative 0.703, and the other one is 2.4, no, 2.370. 2.370. When I round up, obviously I'm rounding. Guys, I'm rounding to the thousandths place. So just stick with the thousandths place. It's nice and easy, and that tells me that you know what you're doing. Okay, I think that's it. Let me just double check here. That is it for the notes.